The gut microbiome is a vast ecosystem with trillions of microorganisms, and within this intricate community, certain microbial families quietly perform vital roles that ripple throughout the body. Among these, Lacnospiraceae and Roseburia stand out as particularly influential, acting as unsung heroes that connect the health of the gut to systemic metabolic and inflammatory regulation. Though they often remain invisible in discussions about diet and wellness, these bacteria are essential contributors to short-chain fatty acid, SCFA, production, inflammation control, and metabolic signaling, making them central players in the maintenance of overall health. Lacnospiraceae is a diverse family of bacteria that inhabit the colon and specialize in fermenting complex carbohydrates and dietary fibers that reach the large intestine. Their fermentation processes produce SCFAs, particularly butyrate, which serves as the primary energy source for colonocytes, the cells lining the intestinal tract. By fueling these cells, Lacnospiraceae help maintain a strong intestinal barrier, preventing the translocation of endotoxins and pathogens into the bloodstream. This barrier function is crucial because it minimizes chronic low-grade inflammation, which is a central factor in the development of insulin resistance, obesity, cardiovascular disease, and even neuroinflammation. Beyond butyrate, Lacnospiraceae members produce acetate and propionate, which contribute to signaling pathways that influence hepatic glucose production, lipid metabolism, and peripheral insulin sensitivity. Essentially, they act as metabolic mediators, translating the fiber we consume into molecules that promote systemic health. Roseburia, a genus within the Lacnospiraceae family, deserves particular attention for its potent SCFA-producing capacity. These bacteria are highly efficient at fermenting resistant starches and non-digestible polysaccharides, generating substantial amounts of butyrate that nourish the gut lining and reduce inflammatory signaling. Butyrate's influence extends beyond the intestine. It modulates gene expression through histone deacetylase inhibition, which can improve insulin sensitivity and support lipid homeostasis. Additionally, butyrate stimulates the release of gut-derived hormones like GLP-1 and PYY, which regulate appetite, enhance satiety, and improve postprandial glucose handling. Roseburia thus functions not only as a microbial fermenter, but also as a systemic metabolic regulator, demonstrating the remarkable capacity of gut microbes to influence host physiology. The health implications of these microbes are profound. Populations with higher abundance of Lacnospiraceae and Roseburia tend to show improved glycemic control, lower markers of systemic inflammation such as C-reactive protein, CRP, and interleukin-6, and better lipid profiles. Conversely, reductions in these microbial populations are associated with metabolic syndrome, obesity, and increased risk of type 2 diabetes. The mechanisms behind these correlations are multifaceted. SCFA production strengthens gut barrier function, reduces endotoxin-driven inflammation, modulates hepatic and peripheral glucose metabolism, and promotes beneficial bile acid transformations. Collectively, these effects demonstrate how specific microbial families act as a bridge between diet, gut health, and systemic wellness. Diet plays a pivotal role in nurturing Lacnospiraceae and Roseburia. Foods rich in fermentable fibers and resistant starches provide the substrates these bacteria need to thrive. Whole grains such as oats, barley, and brown rice, legumes like lentils and chickpeas, and prebiotic-rich vegetables like asparagus, garlic, and leeks all contribute to the growth of these beneficial taxa. Nuts, particularly pistachios and almonds, supply fibers and polyphenol that further encourage SCFA production and microbial diversity. Even polyphenol-rich fruits like berries, apples, and plums can selectively feed these microbes, enhancing their abundance and activity. By consistently including such foods in the diet, individuals create an environment in which Lacnospiraceae and Roseburia can flourish, producing metabolites that positively influence both gut and systemic health. The benefits of supporting these microbial families extend beyond metabolism and inflammation. By maintaining gut barrier integrity, they help reduce the risk of gastrointestinal disorders and promote immune homeostasis. SCFAs influence neuroimmune signaling and may contribute to cognitive health, mood regulation, and stress resilience. Moreover, their role in bile acid metabolism can impact cholesterol homeostasis, cardiovascular function, and liver health, demonstrating the far-reaching influence of these unsung microbial heroes. Practical strategies to foster lacnospiraceae and roseburia revolve around creating a diverse, fiber-rich, and minimally processed diet. Emphasizing plant-based foods, whole grains, legumes, nuts, seeds, and polyphenol-rich fruits provides a steady supply of fermentable substrates. Including fermented foods such as yogurt, kefir, kimchi, or sauerkraut adds probiotics that support microbial diversity and may synergistically enhance SCFA production. Timing and consistency also matter. Distributing fiber intake across meals ensures sustained SCFA production, supporting gut barrier function and metabolic signaling throughout the day. Over time, these dietary patterns can enhance microbial resilience, improve metabolic outcomes, and reduce inflammatory burden, illustrating the systemic impact of nurturing specific microbial families. In summary, lacnospiraceae and roseburia are vital, yet often overlooked members of the gut microbiome, performing essential roles in SCFA production, inflammation reduction, and metabolic regulation. By producing butyrate and other SCFAs, they maintain gut barrier integrity, modulate systemic glucose and lipid metabolism, and influence hormone signaling that regulates appetite and energy balance. Supporting these microbes through a diet rich in fermentable fibers, resistant starches, polyphenol, and minimally processed plant foods is a powerful, practical approach to enhancing gut health, preventing metabolic disorders, and promoting overall well-being. These unsung heroes demonstrate that the gut microbiome is not merely a passive participant in digestion, but a dynamic ecosystem that can be intentionally nurtured to optimize systemic health and resilience.